this. So the lesson 3 is the front of your notes, and lesson 4 is the back of your notes. So they give us this warm-up. I do believe there's a typo on your warm-up. It says -5, should be -6. So fix that on your notes. Okay, so we're solving this quadratic equation. When I solve a quadratic equation, what do I do? Like, what would be? What'd you say, Grayson? What do you mean? We don't want to move the 6. We factor, yeah. So we want to make sure everything's on one side, everything is on one side of the equation, and then we factor. So when we're factoring, we think of two numbers that multiply to be the last number, so -6, and add to be the middle number, which is 1. Right? There's technically a 1 in front of that x. One's going to be positive, one will be negative. Yeah, +3, -2. So when we factor, we write our two parentheses, so it'll be x +3, x -2. And then is that my answer? No, what would my answer be? Yeah, so we technically like set both factors equal to 0. Shortcut is it's the opposite sign. So we say our answer is x equals -3, x equals 2. So that's how we solve. And what do those numbers represent? Like if I were to graph this, what do those numbers represent on our graph? Yeah, so when we solve that, we're solving for the x-intercepts. All right. So that's a little refresh of our quadratics. So the questions, all the problems on the front, like I said, this is lesson 3. So all the problems on the front are what's called one variable quadratic inequalities because there's only x, there's no y in these. So all of these are equal to 0. So the first step, I have like the steps listed out on how we're going to solve these. So our first step is we're going to solve and like get our two solutions. So we're going to factor. So for the first one, we want to think of two numbers that multiply to be 7 and add to be -8. And we're multiplying to be positive, so they're both going to be positive or both be negative, and we're adding to be negative, so they should both be negative. Yeah, -1, -7. So when we factor, it'll be x -1, x -7 equals 0. So then my two answers would be +1 and +7. So when we graph, we're going to graph these on a number line. We're going to still do our circles at 1 and 7. Now we have to figure out if it's going to be open or closed circles, and that's going to come from whatever the inequality was in our original problem. It's an equal to, greater than or equal to. So am I going to have a closed or open circle? Closed. So we want a closed circle at 1 and a closed circle at 7. Now, when we did this stuff yesterday, we like had our inequalities in our answers, and so we already knew where to shade. So with this stuff, we don't really know where to shade. So what we do is we're going to test a few points and see like if it works and like if that's included in our solution. So I always, when I'm doing these, is I work my way from left to right on my graph. So I'm going to look to the left of 1 in this part right here, and I want to see like, am I going to be shading right here? So we choose any number that is less than 1 and we plug it in and see if it works. So that's this part C. This is where we're testing. So it doesn't matter as long as it's in that interval. So as long as it's less than the 1, doesn't matter which one it is. I'm going to do 0 because 0 is a nice number. So we're going to test x equals 0. So we plug 0 back into the original one, so plug it into the inequality. So everywhere we see an x, we're going to replace with 0. So I'm going to do 0 squared minus 8 times 0 plus 7. And we want to see if that's greater than or equal to 0. So that would be 0 minus 0 plus 7. So that'd be 7 greater than or equal to 0, which is true. Right, 7 is bigger than 0. So because it works and it makes our inequality like a true statement, that means that we would shade this area less than 0. Now, yesterday when we were graphing these on the number lines, there was 2 different number lines that we encountered. We either had, when we shaded like they were opposite directions, going like away from each other, or we shaded like in between. So we kind of like that's gonna be only like the only 2 options really for this stuff. So we kind of already know that like we should shade the opposite direction because we shaded to the left. So you don't really technically need to test the other points because you kind of already know what this should look like. But just to show you, I'm going to test something that's bigger than 7. That way I can show you that it'll work and that's going to be the other part where we shade. We're not going to be shading in between. So I'm going to do 8. I'm going to plug in 8. So this would be 8 squared minus 8 times 8 plus 7. So it'd be 64 minus 64 plus 7. So that'd be 7 greater than or equal to 0, which does work. So that means we're going to shade above 7. So then if we tested something in between the 2, it shouldn't work. So just to show you, I'm going to plug in 2 and show you that it doesn't work. So it would be 2 squared minus 8 times 2 plus 7 greater than or equal to 0. So that would be 4 minus 16 plus 7 greater than or equal to 0. So that's like negative 12 plus 7. So negative 5 greater than or equal to 0. And obviously negative 5 is not greater than 0, so it doesn't work. But like I mentioned earlier, once you get one part, you kind of already know like what else is going to happen because you either shade opposite directions or in between. So we won't have to test 3 points on all of them. I just wanted to show you on this one. So part D, they want us to complete the graph, which we already did. Part E, so they want us to write the solution in interval notation. So if we think back to, we've done interval notation before. It's like with the infinities, negative infinity, with the brackets, with the parentheses. So we want to just write, like, represent this graph as intervals. So we always do left to right. So I'm going to start with this part right here. So all of those numbers, that graph goes on forever and ever from negative infinity. Right, all of those negative numbers, we want everything, it's going to keep going. We could plug in like negative 1,000 and it should work. Keeps going forever. And then we stop this interval at positive 1. So it goes from negative infinity to positive 1. So we need brackets or parentheses. Do I put a bracket or a parentheses around my infinity signs? parentheses, right? Because we don't include negative infinity. We can't be equal to negative infinity. And then we include 1 in our interval because we have a closed circle. So do we think we're going to have a bracket or a parentheses? Bracket. So bracket represents the fact that we are including it in our solution. All right, so then we jump to the other interval over here, so the 7. So it starts at 7. Am I going to put a bracket or a parentheses around 7? Bracket, because it's equal to, it's a closed circle. And then after 7, that graph goes on forever, so we want a positive infinity. Bracket or parentheses around infinity? Parentheses. Now, when I have 2 intervals that I like jump from one to the other, what do I need in the middle? The U. Yeah, the union symbol. Because we're saying like this and that together. This interval or that interval. All right, next one. All right, so first up we want to solve, so we want to factor. This one has a negative in the front, so if you ever have a number like that's not just positive 1 for the x squared, we need to try to factor it out first. So we're going to pull out like a GCF of a negative. So we're going to pull out a negative and make this x squared. Or pull out a negative from everything, make that positive 13x, positive 42. So then we want to think of 2 numbers that multiply to be 42 and add to be 13. What did you say, Kushi? 7 and 6, yeah. So positive 7, positive 6. So when we factor, it would be x plus 7, x plus 6. All right, so what are my 2 answers? Negative 7, negative 6. Okay, so looking at our, let's go ahead and draw our circles. So looking at our original problem, it's just a less than. So do we think open or closed circles? Open. So we want open at negative 7, open at negative 6. All right, so now we need to figure out like where are we shading. So we need to do our little testing. So I'm going to do the first interval over here on the left. So we just need to test anything that's less than the 7. I'm just going to do negative 8. So in my equation, I'm going to replace everywhere I see an x with a negative 8. So it'll be negative 8 squared minus 13 times negative 8 minus 42. So that'll be negative 8 squared is 64. And that'll be negative 64 because there's a negative in the front. Negative 13 times negative 8 is positive 104 minus 42. So negative 64 plus 104 is that's negative 2. Is negative 2 less than 0? Yeah, so that works. So that means we will shade less than that negative 7. So with this one, we don't need to test really. Where else should I shade? What should be the other part where I shade? What'd you say, Austin? Yeah, so like greater than the negative 6 over here. Yeah. So you could plug in, like you could plug in 0, it'll work, because we either shade away from each other or in between. And since we already did the first part, then we know that the other part should be shaded. that. All right, so let's go ahead and do our interval notation. So we're going to go from left to right. So I have, all right, so interval notation, our left side is coming from negative infinity. So over here, like we have all those negative numbers up until -7. And then we always put parentheses around our infinities. Am I going to put parentheses or a bracket around -7? Parentheses, because it's open circle. So we don't want to include it. We want to get really close to -7, but we're not including it, so no bracket. What do I need in the middle? The u. Next interval starts at -6, so second interval over here. Bracket or parentheses around -6? Parentheses, because it's another open circle. And then that interval goes on forever and ever to positive infinity, and we always put parentheses around infinity. Okay. All right, so the last two, like I had the steps kind of listed out, so we're going to follow those same steps on this one. So our first things we want to do is factor, get our two numbers. So we want to think of two numbers that are going to multiply to be 5 and add to be 6. Five and 1. So this is going to be x plus 5, x plus 1. So what should my two answers be? -5, -1. Okay. All right, so looking at our inequality, are we going to have open or closed circles at the -5 and -1? Open, because it's just the greater than. So we want open at -5 and -1. All right, so now we need to figure out our intervals, like where we need to shade. So we're going to do first part over here, so up until the -5. Any number that's less than -5, you can plug in. I'm just going to do -6. Always plug it into the original inequality, so it'll be -6 squared plus 6 times -6 plus 5. So that'll be 36 minus 36 plus 5. Which would be 5, which does work. All right, so that works so that we know that we should be shading down here. So then I know that I should also shade opposite direction. Now, if we did it like if we did this -6 and it doesn't work, then we would need to go in the middle and test something. And then if that works, then all you need to do is shade in the middle between the two. All right, so then we also want to do our interval notation. Okay, so it's coming from negative infinity, right? All those negative numbers up until the -5. Am I going to have it a bracket or parentheses around the -5? Bracket or parentheses? Parentheses, open circle. And then next we need our union. Oops. Our next interval starts at -1. It's going to be another parentheses because open circle. And then it goes off to positive infinity. That right side of the graph goes on forever. Okay. What do we notice about this one? Right, it's not 0 on the other side. So before we factor, we want to make sure our inequality is equal to 0, or like the right side is 0. So we want to get everything on one side. So we're going to move the 15 to the left side. So add your 15. It's negative, so we're going to add it to get rid of it. So we would have x squared plus 8x plus 15 greater than or equal to 0. All right, I want you to do this, finish this one. Okay, so if we factor this one, we want to think two numbers that multiply to be 15 and add to be 8, so you should have gotten 5 and 3. Positive 5, positive 3. And then your two x's would be negative 5 and negative 3. So do we want open or closed circles? Closed, because we're equal to. So we want negative 5, negative 3. All right, so then we want to test. So I'm going to just go to my left interval. Any number less than the 5, so I'm going to do negative 6. So plug that in. Now you could plug it into the original one and see if it's going to be greater than or equal to the negative 15. Or you could plug it into the one where everything's on one side. Either or, doesn't matter. They're the same equation, they just look slightly different. I'm gonna plug it into this part. So negative 6 squared plus 8 times negative 6 plus 15. So that'd be 36 minus 48 plus 15. Which should work, should be 3. So that does work. So we want to shade less than the negative 5. So that means we know that the other part we need to shade is the other way. All right, and then for our interval notation, the left part is coming from negative infinity up until negative 5. Bracket or parentheses around negative 5? Bracket, because we're equal to, we've got a closed circle. Union, because we're jumping to our next one. Again, another closed circle around negative 3. This is a closed circle, so we include it in our solution. And then that goes off to positive infinity forever. Right. Okay, so that's our one variable. So then we're going to get into our what's called two variable quadratic inequalities. So these have x and then we have a y on the other side. We don't have a 0 on the other side. So we're actually going to graph these on our coordinate plane. But first they give us 3 different examples and they want to see similarities and differences. So if you notice, what are some things we notice? Similarities, differences, about the equations, about the graphs, anything. Austin, give me one thing.
If the line is dotted, then it's not included. Or it beat that open.
Okay, so you're thinking, okay, so this one, it's not included. It's just a greater than, and then when you see the graph has a dotted line, so that would be similar to an open circle. That's what you're saying? It's good. So, okay, so we noticed that, I guess it's one of our differences. So if it's an inequality that's not equal to, then we have a dotted line. And like Austin said, that would kind of be an open circle on our number line. Okay, anything else we notice? Similarities, differences? Cushy? They had the same x and y intercepts. Okay, so did you see that from the graphs or from the equations? So first the graph, then the equation. Yeah, so if we notice, they're all the same graph, but they're all the same equation. If we look, they all are x plus 4, x plus 2. And then if we look at the graph, they're all crossing at negative 4, negative 2, negative 8. So they're all the same equation and graph. Just the difference is that, like, this first one's an equal to. The second one is a greater than or equal to, and then the third one is just a greater than. So that's one of our differences, is that they have different inequalities. And then the last thing that I'm kind of noticing is like this, like there's some kind of like shading going on with the second and the third one. Right, the first one is just the parabola, but then like these two like have this region above the graph that like is shaded in. So like the middle and the last one have some kind of shading.
So they have like way more than 2 answers.
So like the first one is a normal parabola that we've seen before. You just graph it and like you only could plug in ordered pairs on the parabola. But with these inequality parabolas, that means if I were to plug in any ordered pair in the shaded region, plug it into the inequality, it would also work. Okay. So we're going to start graphing. So the steps when we're graphing, the easiest thing to do first is find your x-intercepts. So we're going to factor like we've been doing and find our x-intercepts. So for this first one, it has a negative in the front, so let's factor out a negative and make that x squared plus 4x plus 3. So we want to think two numbers that multiply to be 3 and add to be 4. Three and 1. What? All right, so my two answers would be -1, -3. So that's where the graph crosses the x-axis. I'm going to go ahead and put it on my graph. So we're going to cross at -1 and -3. Okay, so now we're going to find the vertex. The vertex is like the highest or the lowest point on the graph. So we first are going to find the x value of the vertex. So we use this little formula, x equals -b over 2a, to find the vertex, x value of the vertex. Now this parabola, this quadratic is in standard form. Standard form is ax squared plus bx plus c. So when we're plugging these numbers in, b is the number in front of x, a is the number in front of your x squared. So b in this case would be this -4. So opposite of b is -b would be +4 because it's already negative. And then we divide by 2 times a. A is -1. So this is 4 over -2. So -2. So your vertex is an ordered pair, right? It's the highest or lowest point. So that's the x value of the vertex. So we have to plug it back in and figure out what y is. So we're going to plug in -2 into the equation and just see what we get. So let's go. So everywhere I see an x, I'm plugging in -2. So it'd be -2 squared -4 times -2 minus 3. So that would be -2 squared is 4 with the negative front, so it's -4. -4 times -2 is +8, and then minus 3. So 1. So our vertex is at -2, +1. So I'm going to go ahead and graph that. Alright, part C, they want us to identify the y-intercept. Now, when we're in standard form for a quadratic, we can see the y-intercept. What did you say, Brandon? Oh, someone said something. Or that was just a yawn. Oh. Okay, so we can see it. Your y-intercept is equal to whatever your c is in your equation. So c in this case would be -3. So your y-intercept is going to be at 0, -3. So whatever the last constant number on the edge is, that's your y-intercept. So I'm going to go ahead and put that also on my graph. And then one more thing that we can graph. So all of our parabolas have an axis of symmetry. What's an axis of symmetry? Alright, so lots of things. So I heard you can cut it cuts in half and it reflects over itself. It's the same on both sides. So it's like that imaginary line that goes through the vertex. And when you cut it in half, everything on one side of the parabola is the same on the other side. So with the y-intercept, what we can do is we can count how far we are from the axis of symmetry. So I'm 2 units away from the axis of symmetry. So I could go 2 units to the left and mirror it over the axis of symmetry and get another point on my parabola. When you're graphing these on your homework and stuff, you only really need 3 points, but sometimes you might not be able to see the x-intercepts nicely, and sometimes we might need to do this mirroring situation. So I just wanted to show you that on this one. Okay, so let's finish our graph. So we were talking about the open versus closed circle, that is going to be if we're going to do a solid or dashed line on our parabola. So because this one is greater than or equal to, that means we can be equal to the parabola. So when we connect our dots, we want a dashed line. Sorry, a solid line. So we can be equal to the parabola, so let's connect our dots. We want solid line. All right, so then with the parabola, we have to shade because this is an inequality. Because we can include multiple points. So it's a greater than, it's facing towards the y, so we want to shade above the parabola. So however you want to shade, I just do lines. So this is above the parabola. So what that means is if I chose an ordered pair in the shaded region, so say it could literally be any ordered pair 2, 3. If I were to plug in 2 for x, so if I were to plug in, I would have 3 over here for y, and then I replaced every x with 2, that should make a true statement. Whatever I get should be less than the 3. That's what that means. So any ordered pair in our situation in our shaded region would work. If I chose something not in the shaded region, so something down here, so let's say -3, -3. If I were to plug those in, I should get something that is not a true statement. So that's what the shading means. Okay. All right, so this one is in a different form. It's not in standard form, it's in factored form. They already factored it for us, so we can see the x-intercepts more easily. We don't have to factor for this one. So the whole opposite sign thing only works if it's in this form, x plus 2. So x equals -2 would be one of our x-intercepts. So when we're doing that, when we're trying to find our x-intercepts, what we're doing is like we're technically setting both of those things equal to 0. We're saying x plus 2 equals 0 and -8 minus x equals 0. So the other one, like the -8 minus x looks kind of funky, so we're going to go ahead and set them equal to 0. So x equals 2, sorry, -2. That's one of our x-intercepts. And then for the other one, we would have to add the 8. So we get -x equals 8. And then divide both sides by -1. So x equals -8. So we cross out -2. I'm going to go ahead and draw my x-intercepts. -2, -8. All right, so next we want to find our vertex. Now we want to use a little x equals -b over 2a formula, but we can't see b and we can't see a when it's in this form, so we need to FOIL it out and change it to standard form. Find our vertex. So we're going to FOIL this out. So we'll do -8 times x. So -8x. -8 times 2, which is -16. -x times x would be -x squared. And then -x times 2 would be -2x. So we want to write it in standard form. So the x squared always comes first. So -x squared. And then we could combine the -8x and the -2x to get -10x. And then we got the -16 on the end. All right, so now we can see our b, now we can see our a. What's b in this case? -10. So if it's -b, it'll be +10. And then it's 2 times a. So 2 times, what's a? -1. So it's 10 over -2. So -5. So our x value for our vertex is -5. Then we're going to plug that in and figure out the y value of the vertex. So you could plug it into the original one or the standard form version. Doesn't matter. The same equation, just they look different. You get the same answer. I'm going to do the standard form one. So I'm going to do -5 squared minus 10 times -5 minus 16. So that'd be -25 plus 50 minus 16. So 9. So our vertex is at -5, 9. So we'll go -5 up to 9. Okay, so for this one, what's the y-intercept? -16, right? The last number in standard form. So we can't really graph that, it's kind of off our graph. So we have 3 points, so we're good. So we want to figure out if it's going to be solid or dashed line. It's just a less than. So what do we think, solid or dashed? It'll be dashed. So we connect our dots, we're doing dashed. We're not going to cross the y-axis, so down at -16, so don't cross it yet. And it's a less than, so we're going to shade below the graph. So this time we went down here. Okay. Last one. So this one, there is a number in front of the x squared. So when we factor, we want to think like, could I pull that 2 out, just pull the GCF out, and then normal factor? Could I pull out a 2 from everything? No, so if we cannot pull out the number, what method do we do? Cloud method. So we're trying to find our x-intercepts or factoring. So 2 goes in the cloud. So that's x squared plus 15, or sorry, minus 15. And then what do we need to do with the 7 on the end? Multiply by 2, so 14. So then we want to think of 2 numbers that multiply to be 14 and add to be -15. They're both going to be negative because we're multiplying to be positive and adding to be a negative. Yeah, to be -14, -1. What do I do next for cloud method? Divide by the 2. So we try to simplify. So we can do 14 divided by 2, that's 7. And then we can't simplify the 1/2, so we're just going to leave it like that because we're trying to solve. Normally, like if we're just factoring, we move it in the front, but we're just going to do our opposite signs now. So +7, +1/2. All right, so I'm going to go ahead and put those on my graph. So +7 and then 1/2, so halfway between 0 and 1. So now we want to find our vertex. So we're going to do x equals -b divided by 2a. B is -15, so if it's -15, -b, so it'd be +15. Over 2 times a is 2. So we have 15 over 4. And for these, just go ahead and give me some decimals because we have to graph and we need to see like what the decimals are. I think it's 3.75. So then we need to plug that back in. That's the x value of the vertex. So we need to plug that 3.75 into our function and figure out what y is. So it's going to be y. We're going to do 2 times 3.75 squared minus 15 times 3.75 plus 7. So it's, do this part, it's 28.125 minus 56.25 plus 7. Then add everything together, I think you get negative 21.125. Okay, so 3.75, so like almost a 4, and then we're down at negative 21.25, so a little bit past, halfway between 20 and 22. Doesn't have to be like completely accurate, just close enough. Okay, we also could do our y-intercept on this one. What's the y-intercept? 7. Yeah. So we could grab our y-intercept. So we cross out 7. Okay, so am I gonna have a solid or a dash line? Dash, because we're just the greater than, so we're gonna do dashed. And then are we gonna shade above or below for this one? Above, because it's greater than. So we want this part right here. Okay, so before I give you your assignment real quick, if I give you something, you're going to see this, and I just want to review this. You're going to see something like y is greater than x squared minus 25. How would I factor that? Yeah, it's the difference of squares, so we're subtracting a number that we can square root nicely. So, it's always x, one's positive, one's negative, and then it's whatever the square root of 25 is, which is 5. Now it's like really squished, sorry. So it's x, and x plus minus, and then 5 because that's the square root of 25. So you will see that on your homework, so I just want to go through that.